Uh, Good afternoon, everyone. I welcome you all to this 10th module of Security and Internet of Things. We will be talking about access control, or what happens if our access control is like insecure. So, if we talk of the network that we are accessing today, or computer networks or internet, so these are all based on role based access control. Like role based access control is is an access control mechanism where first you have to prove your identity, and then you can use the what you call as use the network. Take an example, like if you walk in a library and show your identity that I am so and so, you'll be depending upon the capability of a student, you'll be able to get 2, 3, 4 books issued as if for max. And if I walks into the library of our university, at ease I'll be able to get 10 books issued for myself, and with the permission from my head of the department I can even elevate to 15 books. But if vice chancellor sir goes and get himself a book issued, then he might have access to like jitni wo pad sake. There will be no upper cap on it. So this is something which is known as role based, and we have been dealing with it on the daily basis. And this role based applies to most of the existing networks, existing network authorization systems and protocols like IPsec, Radius and all. Now 90% of these online applications, they commonly rely on, maximum online application, they commonly rely upon HTTP cookies which are stored in your browser. And once the identity has been verified, you can access whatever you want to access depending upon your capabilities. That does not mean that app you will be able to go into the backend and fiddle with the program of that application. So this individual authorization systems, they differ on access control systems. They basically differ in a way in which they in a way they what do you call as they develop the identity of a system. So every system, every network, it has its own way to set the identity of the identity of an entity and grant access to its resources. So there are basically a couple of access control mechanisms which will be discussing, and will be talking about their incapabilities. So role based, as we discussed, is basically a access control system in it is in computer, a laptop computer also, and that is basically not suitable for the Internet of Things. Why? Because there are million of devices, and there are so small nodes which are suppose there is some sensor node that is which we talk about generally, sensor node that has been deployed to detect the forest fire, a temperature sensor. So each and there's so small sensors that the main network would never be able to what do you call as entrust the identity that would be provided by the leaf nodes. So this identity of individual device in role based access control may not be known. If we talk about the parent server, it may not be known, may not be established, or at times it doesn't matter also. So this role based access control is typically based on based on some rules or some what do you call as criterias, or their positions, or maybe geographical locations, or architecture or other. But establishing these kind of things or implementing these kind of things in IoT, एक छोटे से scenario में भी जैसे अगर suppose I place some IoT sensor in your room, so without it is not necessary that it will be able to automatically control the light of your room. Getting my point? So that entirely depends upon what is this and what is the scenario. So this is basically a, if there is a temperature sensor, it will sense the temperature. It cannot control the fan or what you call a luminosity of the individual. So role based is something that depending upon who the person is, resources are allocated to him. But for IoT network to identify each and every smart device present in this planet would be typically impossible. So role based access control systems are not that much what you call as suited for IoT devices. Then another base of access control systems is basically ACL, that is access control list based systems. So access based control list systems, basically they maintain a table. They maintain a table of each device present in the network, and in this table they maintain what kind of resources they can access, what kind of resources they can access. Each sensor node or entity as an security attribute that that is presented to ACL whenever it is trying to access the what you call as network. So access control list, basically they have capability of either allowing you or rejecting you to the gaining the network. It is something like you go to some what do you call as cantonment area. So you can access the cantonment area in Dehradun, but there are certain areas inside the cantonment which are barricaded. Once you have to enter there, you'll have to present your identity. On the other hand, suppose the car of a brigadier is coming up, he'll automatically identify and grant him the access to that node. So these ACL are basically two types of ACL which are currently deployed, which I have read till date. One is file system ACL, another is networking ACL. File system is basically access to files or directories which are stored in a system. This file system informs the operating systems which of the user can access which of the user can access the system and up to what extent they can access the system, what are the what you call as resources that can be made available to the user once he requests for them. Then networking ACL, it is basically access to the network. It is basically a filter to access the network. So it tells routers and switches in the network that which type of traffic they can allow through the network and which type of traffic they have to deactivate. And does not allow over the what you call as network. So ACL was generally it was the only way to achieve firewall protection, but today there are many options available. I guess you, being the computer people, must be knowing many more than I know, but generally this if we talk of today, many software organizations, they are still continuing to use ACL and parallel with some other technologies like VPN or so. So basically the advantage of using ACL, you get to control the traffic. You pass on what you wanna pass through the network and what do not wanna pass the network. Then you can restrict unnecessary messaging and communication to alleviate the network performance. Then obviously it provides a level of security. It provides a level of security, and most importantly it allows you to monitor at a very small level any traffic that is entering your network from any of the resources. This ACL would allow you to what you call as monitor that. So this is the ACL, and the last one is capability. You all might be knowing of this capability based system. So capability based system, if we talk about the what you call as capability based access control system, you do not have to produce your identity. You do not have to produce your identity. A lot of research is being done, and a lot of IIT networks, they are based on capability based access control systems because of this identity thing. This capability is basically a cryptographic key that gives the access to some of the ability, and it is defined next to the what you call as next to the identity of the this what we say as the identity of the network, the identity of the network. So, in capability approach, you do not have to override. If you are using this a capability based access control system, you do not have to produce your what you call as, you do not have to produce your identity. That means you do not have to authorize yourself to access the network. That is one of the what you call as what you call as advantage that is offered by this capability based access control system. But then this capability based access control system, let's this is like, it was introduced very early in, I don't exactly remember, but it was somewhere introduced in 60s, and it is basically you go to a movie theater, present a ticket, and this doorkeeper will give you an access to the theater. Same ways, you produce the ticket and you gain the access to the network and computer to the system. Your role is basically automatically defined behind the with the ticket. Now, with a movie ticket, you have a capability to enter a theater with the key. You have a capability to enter the house, and same ways, if we talk of the programming language or data structures, to they contains whenever you define something, you define a identifier, and that is next to it you define what you call as access rights. It is like, if you have to write some process x comma x is equals to x comma a is the access rights, and right to read, write, execute, delete, whatever it may be. Now, using these capabilities can be either, it can be used in a explicit manner or it can be used in a implicit manner. Now, explicit manner is like you have to show present your capabilities. For explicit, you have to present your capabilities. This is what we do when we enter any movie theater. You show the tickets and he lets us in. Like, if you have to, if we are writing in a suppose I have to access anything, then I write PUT bracket पे file underscore capabilities and then comma curly braces and write this is a record. So I will be able to access the file which is named as this is a record. Now, implicit use is like, there is no need to show the capabilities, but the system will automatically check what are your capabilities and what all resources you can check. Matlab, it is something like that, you go and sit in the movie theater, doorkeeper will come and check your pockets for the tickets. So it does not sound a very appropriate idea, but computer system mein, it is like this only. The capabilities list method basically use this approach only, and each process carries a list of capabilities. When it tries to access an object or access a control system, checks this list to see whether the process has right capability or not. Getting my point? Unlike this explicit approach, in implicit approach, processes or program or programmer, they really do not need to care about what capabilities should be presented to the system. So implicit approach is not that efficient, especially when the capability list is long. If the capability list is long, but it might be easier to use, and capabilities are transparent to the users. One of the problems with the capability based system is that capability cannot be erased, it has to be transferred. So work is being, work is actually going on these things, and it will be soon some good solution would be there. So some challenges, if we talk about the challenges in access control system. So in access control system, there can be, for Internet of Things, there can be thousands of challenges, like weak passwords. I was reading some article the other day. It was reported that around 20% of the applications that we keeps on downloading on our mobile phones, they do not use SSL connection for the SSL connection to the network through the cloud, and this can allow any of the hacker to access our mobile phones, and we can be prey to MIMT attacks, man in middle attacks. Now another thing is that most of the many devices, they are unable to provide the mutual authentication comparison between the clients and the server then passwords, although everywhere set a strong password, I do not, there is no single day when I see that some or the other password is compromised. Reason being, this passwords we generally based on username, date of birth, car ka number, bike ka number, and all, and with IoT system or IoT device, the problem is that more complex strong passwords are not supported at a time. Now if we see go slightly ahead and talk of IoT cloud interfaces, then they at times, many of the devices, they do not support two-way authentications, and lot of these things. So generally if we see, then 90% of the Janta on the globe, they use weak password, and this is basically a this has been a greatest security issue ever, and this is constantly being seen for the IoT devices. So in order to devise a rugged IoT network, we should for access layer, we saw the challenges for the access layer previously, and for access layer, we should ensure that security standards for Internet of Things and are properly implemented, and make sure that all the entities that are being manufactured, they should meet the ITU's security standards. Then another thing, to develop this thing to evade the threat to access control and privacy, we should ensure that trustworthy data sensing systems should be built, and review the security of all devices producing this data time and again, and regular checkups for the produced devices should be done. Then for complex networks, it should be ensured that for complex data and complex information, for critical information like health information or defense information, anyone, maybe he is accessing that information from his jet or his ship, or sitting to 5,000 miles away from us, any which way the system should be able to trace back the user, whoever is accessing the complex data. Then these softwares, which actually these devices are nothing without operating system. The operating systems and software should be designed in a way so that they are least vulnerable to what you call as to the online threats. because these insecure web interfaces and not able to produce identity and not able to develop a what you call as authentication can cause n number of threats to the network. And n nodes, they already, we saw that n nodes, they already have lot of vulnerabilities. So to develop secure IoT standards, this access layer should be designed properly, and all these attacks, unauthorized access, availability, spoofing attacks and all, we had talked of them previously. I hope you all remember them. That's all for this module. Thank you.